Thanks so much for making time today to join us for our noon REILS series. I will highlight and point out that the sessions are now starting at noon rather than 11:30, as was the tradition. So this is our new tradition moving forward. I'm really delighted to see all of you here and to welcome our guest today, Valya Kuskova, and she is actually the managing director of the Notre Dame Analytics Indiana site on behalf of the Lucy Family Institute for Data and Society at Notre Dame. Valya has extensive corporate and academic experience. After receiving her MBA from Boise State University, she'd worked in a variety of corporate roles, from programmer analyst to senior strategic planning analyst at major Fortune 200 companies. Following a master's in applied statistics and a PhD in business and decision science, both from IU Bloomington, she has spent over 10 years in academia. In addition to academic responsibilities of research and teaching, she was the founding director of a network-analytic think tank and founded and supervised 2 master's programs in advanced analytics. She has a lot of experience working for corporate clients such as Coca-Cola, McDonald's, Volkswagen, the Association of European Business, and many others, where she has held roles of PI, co-PI, or advanced analytics methodologist. Her research interests include network modeling, time series analysis, and non-parametric methods, especially for efficiency and effectiveness analysis. She is passionate about using science for the benefit of industry and science, and we are delighted to have her join us here today. Welcome, Valya.
Well, thank you for the very warm welcome. I was asked to include these 2 slides in my presentation. So the first one has the text for attendance. And the second one, I think this is a requirement. I have to state that I don't have any conflicts of interest. I really don't have any conflicts of interest. So we can move on. So today I want to talk about application of network analysis to medical research and some of the possibilities. I want to specify also that this is social network analysis, not just any network analysis. And we'll talk about the details in a minute. It's hard to explain sometimes what you do, but you work in the medical field, so you probably see this all the time. When a physician introduces themselves, they would say, I'm a physician, I'm a medical doctor, right? And once you get to know them better, they will say, well, I do bariatric surgery. And then once you get to know them a little bit better, they'll say in pediatrics. So they're really, really specialized. But when they first introduce themselves, just the fact that they're physicians is enough. So I introduced myself as a data analyst, but then there are several layers of specialization in that. Now, in my role as a data analyst, I often get a question asked, what is data analysis? Data everywhere, people are overwhelmed by the amount of data that they see, and they're talking about structured, unstructured. It used to be that data were numbers. Those days are gone. So to me, data analysis is a good story. So I'm sure you've all done some kind of a data analysis, and you have probably also have heard of networks, I suspect. But so those of you who have heard of networks, bear with me because this is a very introductory lecture. If you have more involved questions, we can talk about that. But when you are doing data analysis, you are trying to tell a story with that data. Sometimes these stories have impact. For example, this is a very known in network analytics field, Hartford drug users, where in Hartford, Connecticut, people were approached literally on the streets. They were drug users and they were asked to answer some questions. Not the most responsive audience, I suspect. It wasn't my study, but I have lots of respect for people who have actually done it. We have 293 people who have answered the questions, and they were also asked to name people that they know. That's the acquaintances. Now, there are some variables there. We had ethnicity and we had gender. And typically when you have these descriptions in a network context or any context, you would do some kind of a visualization. Lots of times academic papers have just descriptions, but you do visualization of some kind and you would give a table, right? So we have some people, 200 who are male, we have 86 female, 7 unknown gender, and then we have some distribution of their ethnicity. Now, when you're looking at these numbers, they're probably telling you something, right? Typically, they say that in data analysis, it's good to provide some kind of visualization of that data because we as humans are highly visual. And we do bar charts. So is it better when it's in a table versus an image? I think it is, especially if you color it by gender. You can also color it by race. But what does that really tell us about the people? Well, some people would probably tell a story from just the images that I've shown here, but this is where I go into my specialization and then even more narrow specialization. Remember, I've mentioned that we asked these people, who do they know? So we build a network from that data. Network analysis is immediately inferential. You know how some statisticians divide statistics into descriptive and inferential? Network analysis is immediately inferential because when you look at this picture, you don't know anything about network analysis, let's say. You see this for the first time. What you see immediately is that there is this giant component connected together, and then there are lots of nodes scattered throughout. Those are the people that didn't want to tell us about who their acquaintances are. But a lot of them know each other. So we have 293 random people in Hartford, Connecticut that are using drugs, and they're all using it together. Okay. All right. Well, but then we can dig one level deeper because we have attributes. We have characteristics such as gender and ethnicity. And if we color this by ethnicity, then we see a completely different picture. I don't know how it is seen on the big screen, but you should be able to see that the giant component of all connected nodes is immediately disconnected once you add the race. In fact, there are only two nodes in that big giant blob that are of different races that are connected together. We cut those two ties, and our drug users are connecting by one very important characteristics only. So if we talk about just the bar chart, it's informative, but not nearly as informative as network analysis. So this is a short story about me. This is what I do. I dig through the data to find information that's hidden or obscured at the first glance. And today I want to share with you one of my passions. I have several specializations. So I want to talk about what networks are. And I'll do it in pictures. I think when it comes to networks, pictures are indeed worth 1,000 words. We'll talk about social networks analysis. I want to mention that network analytics as a statistical tool is completely indiscriminate. It doesn't care who we are connecting, because in a network sense, the unit of analysis is a dyad. So in typical statistical analysis, when we analyze something, we take a singleton. We say we have patients, and we analyze each one of them independently from the rest. In fact, most all parametric or distributional statistical tools require us that our data be IID, independent, identically distributed. Network not only ignores independence, it in fact models it explicitly. So our unit of analysis is two singletons with a possibility of connection between them. From the network analytic perspective, it doesn't matter what we connect or who we connect. We connect people or we connect cell phone towers. But there is a very important difference in social network analysis because social creatures are capable of cognitive decision making. They choose who to connect to. So if our hard drug users were cell phone towers, we would not have seen the differences between races. They would have been completely random. For humans, that's not the case. So when we talk about medical field, the social aspect is extremely important. So I will focus on the social aspect. And I'll talk about the role of networks in general, applications of social network analysis in general field, and then we'll go to where your passions lie, which is applications in medical research. So without further ado, networks have been around for a while. And this is, in fact, a Roman road system network that's very old. It's about 250 AD. And it's one of the few known true network pictures where nodes are somehow connected. Now, medicine is fascinating. I try to pull as many medical pictures as possible, given the audience. This is a protein molecule, and it is a network. It is a network of components, atoms of that molecule, and even one disconnect in that molecule creates a completely different network. So we know that. Now, this is a cell, and a cell is also a network. And in that cellular network, there are important processes that are happening that if we understand their connectional composition between the any two pairs of nodes, we understand a lot more about the cell. Now, this is a true neural network. The original neural network came from medicine, and the neural network analysis that's taken the world by the storm now has this term neural that came from medicine. But this is C. elegans, and it's 302 nodes, and all of them connected to perform the bodily function. This is one of the first fully mapped neural networks in the world. This is the network of wine, and some people can argue this is not medical, but let's say, hey, it's genetics. I was surprised to learn that all wine we drink and all the varieties comes from one single grape, the Traminer. So that was the origin of all the wines we have everywhere in the world. So all other grapes are related to Traminer by some relationships, such as sibling relationships, parent-child, or two parents, one child. So that's kind of the network structure of that wine and where it came from. This is the internet, at least very, very small portion of it, because at this point, I don't think you can grab internet with all the nodes, but back in 1999, we could. This is a network of internet service providers active as of 1999. That's just, I don't know, what, 6-7 years before internet became fully available to public. So at that time, that map of internet service providers, ISPs, was available. At this point, of course, we can't draw a map like that anymore. But so in that dyad, that's a unit of analysis for us. We have the possibility of, there are 4 possible dyads. A null dyad, which means 2 nodes are not connected, but it's still a connection. Absence of a connection is still a connection. It could be one directional or 2 directional. So in this network of internet, obviously everything is bidirectional. Now, you have probably, if what I'm showing you is familiar, but you have not heard the terms I'm using, then what you have studied is called graph theory. Graph theory is old. It's, I would say, 300-400 years old. Network analysis is 1933, because at that time, Jacob Marino had no idea. He was a sociologist. He didn't know anything about graph theory, but he supposed that human connections are important. So he drew those connections on a piece of paper and published that in the New York Times and called it a network. And so social network analysts have reinvented the wheel and developed their own terminology. So we have nodes and links as opposed to vertices and edges that have existed for 200-300 years before us. So there is absolutely 2 network analysts that I consider myself to be. There is no difference in terms. If you talk to a graph theorist, they will be very offended if you call a tie as opposed to an edge. There is a difference. So we have 2 dots with a possibility of connections between them that are called either ties or edges or arcs, depending on the terminology. That's not really that important. But since 1933, networks became a prominent part of social studies and how they impact people. So this is another one of those interesting pictures. This is Countryside School District publication from 2001. And we have little kids, right, from grade 7 all the way to grade 12. And I think there is a very clear distinction between grades. The little ones, the purples and the pinks are hanging out together, and the older ones, all other colors are hanging out together. But then, of course, we also have to color it by race. And once we do it by race, it does not matter which grade they are. So some of these important characteristics manifest through this looking at that composition of a school through a different lens. Networks exist now in literature. This is Harry Potter. And I actually, I'm proud to say that I have never read any Harry Potter books and never seen any Harry Potter movies. So I have no idea what this network tells us. But then there is a Lord of the Rings. And I've read the books and I've seen the movies and I have no idea what this graph says. Because it's some groups, right? It's some groups in that very massive, very impressive literature composition. But to me, Harry Potter here makes more sense than Lord of the Rings. But people try to draw all of that. I mean, they're trying to find sense in scenes and in movies and trying to get additional meaning from it. This is the money networks. Networks are everywhere, literally. This is a picture from, just over 10 years ago, when the money network of social networks in the online media was worth 71 billion. I think Musk, he did buy the Twitter. Eventually, she just bought the Twitter alone for half of that. But at that time, it was a substantial amount of money. And with the social networks, so online social networks, it became very easy to talk to people about networks. But when we talk about social networks, they immediately think of Facebook, Twitter, LinkedIn, and many other means of connecting that we have. So that's why I want to bring up that we're actually connecting in a social network sense since 1933, and in a human sense, since we were sitting by the fire with stones as instruments. But we are calling it social network analysis since 1933, and now we have these online tools. Now, networks can also be dynamic. And one thing that I want to share with you is being a social network analyst, of course, I raised a child who was curious about graph theory, and he wanted to just take a play that was a dragon play that he looked at school, and he created a movie out of it. You see the development of the story, where every time a new character enters or exits the story, it's another scene and characters change. They are also changing in size. The size of a node here means how many times the character appeared in the play. This is a movie about Lancelot, and you are seeing Lancelot grow, but somehow this Lancelot has a cat that he talks to, and all of a sudden the cat becomes a very important character. And then there is, of course, the girl that he loves, and then he's trying to kill the dragon. So right now we're at about the point when the fight happens, and once the fight happens, Lancelot is injured and he disappears, and all these characters separate. So this play goes on, and then when it reaches the culmination point in about 2 more seconds, we see who are the remaining players are. So this tells a story slightly differently than it is being told in the play itself. But imagine we have networks dynamics on a medical case, or a network dynamics on the COVID spread, which is exactly what epidemiologists do. They model these dynamics, they can predict what is going to happen. And this is a very, very powerful instrument. So I'm going to repeat it one more time, that network data are two components as opposed to one. So we have those singletons, we call them vertices or nodes anyway. Those are individual units, they're connected by links or ties. Absence of a tie is still a tie. And they could be directed or undirected. And directed ties means I like this person, they may not like me back. Undirected tie is I'm married to my husband, he's automatically married to me. So that is undirected or mutual tie. And we can still analyze network data the same way we analyze everything else, because these individual nodes have attributes such as gender and their individual body composition numbers that we can analyze. What we also do is we look at how their relations to other people around them affect what is happening. So that's just kind of a basic story what networks are. So let's talk about the social aspect of it. Why is social so important here? Well, it's important because we're social creatures, but also because traditional models of statistics look at social and economic behavior. So people try to predict market crashes. They're looking at financial numbers, thinking that they somehow tied to economics, they're somehow tied to what is happening maybe abroad with different political events. That is true, but they're also very tied to invisible connections between people. Elon Musk has a lot of, I don't know why I keep picking on this guy, but he has a lot of influence. He tweets something and then the whole world runs around discussing what it is, right? So he's like, mega influencer, what they call. But so the network analysis is actually embedding all of it. It's looking at large market numbers, but it's also looking at human behavior as it is explained by these invisible connections, because we are connected to each other. None of us are truly independent. The way we think, the way we dress, the way we talk has a lot to do with our environment and which environment we're in and how we were raised. So a lot of things we are not even aware of because they're part of the culture and upbringing. But that culture and upbringing was generated by the social circle around us. So relationships matter to people, and social network analysis studies that interconnections between people in particular social contexts. Social is by definition relational, and social cannot be without any relations. So we are actors in those social relations, and we make decisions non-independently based on the social surrounding. So this social network analysis focuses on these relationships among social entities. Now, the patterns that we see could be very, very different. Right now, I have 4 nodes A, B, C, and D, and I have 3 nodes tightly connected together, and node B is out there on their own. Between just any of the 3 nodes, I can make 16 distinct connections that form 16 different what we call triads. And those are 16 patterns of relationships that would inform behavior and habits and everything else. And in many cases, depending on what type of relationship within just the 3 nodes, we can make a very different, very drastic decision. The way that we approach building these relationships is by asking people questions. For example, who is your friend? People name these friends, and especially if we're in high school, once we have everyone naming everyone, then we can see the connections between people. That presents a problem in medical research because lots of times people can't talk about their connections, or we cannot disclose those connections. We can still build networks that are called ego networks. That means that we talk only to our patient, and we talk about people that surround our patient, and we build those separate networks that would be very, very different. I will show you an example a little bit later today from one to another. So the networks are very special types of analysis. It's my passion for many different reasons. Because first of all, in traditional social sciences and now in medical sciences, we only are concerned about monadic attribute, which is individual only. When we are looking at network context, we are looking at the dyadic attribute. When we are working with a patient who is a part of a family unit, how does that patient's well-being affect well-being of other people around them, and how they're making their medical decisions based on who is a part of that family unit. So we have to consider many more variables when we work with network analysis. Now, networks are also special because it's a combination of very advanced mathematics, it's graph imagery, advanced math, but also they're grounded in very strong empirical data. It's like the best of all worlds. Qualitative researchers understand networks very, very well because they talk to people, they hear about networks all the time. Now, moreover, networks are non-discriminant in terms of a level of analysis. Those of you who are hardcore researchers know the basic tenet of research: never cross the level of analysis because you're losing variance. Well, networks not only allow us to cross the level of analysis, they also allow us to explicitly model that crossover. So instead of building multi-level models as we do with regression and then rolling up that connection between the levels, that beta coefficient in our regression, we can do it on individual level. How do people aggregate from individuals to form a team? And we can distinguish between different teams on specific network characteristics, because network analysis provides us with additional information. So for every network, we can calculate what is called density. How dense is our network? Density of 1 means that every single person is connected to every single other person in the network. Density of 0 means nobody is connected to anyone. Now, whenever we start making those connections, we have people. Then for directed ties, we have P times P minus 1 possible connections. And that's a lot of connections, right? So we have that density, and let's say we have 2 groups of 10 people each, one performing, one not. We just by looking at the density of those groups, we can say this group can never be efficient because they're too tight. They're forming a clique. To be efficient, some people have to have access to information that other people do not. We don't want the very high density for a working group. Each one should have their own expertise, not know everything about everything. So just that density alone tells us a lot, but there are many, many, many other statistical parameters that we can calculate on these connections between people. Networks also model social dynamics. We have network structure, how the networks are connected together, is informing a lot of things that are happening with actors' attributes. So imagine the situation that I'm sure you have all been in. You enter a new group, like the group I entered right now. I've met a couple of you previously, but I don't know anyone else. So today, for my first conversation, I'm naturally connected to people I've met before. So same with children, when they enter a new group, they look at how other children behave. Are they sitting in pairs? Are they sitting in a group? That's how they make their decisions. And based on how other children behave, they start to behave a certain way. If it's a kind environment, these children will be kind. If this is a fighting environment, they will fight. So the structure of the network informs their behavior, which in turn informs the structure of the network, because the next child who comes in is going to form the same structure. So there are two major questions that could be addressed: is what explains emergence of ties? Why do people form the ties? And there are two explanations that are major. First, it's characteristics of the node, who I am. The second one is the network itself. How I act will depend a lot in what is happening in the network. Now, what explains emergence of the attribute? How is the same child who was performing very poorly in one school all of a sudden starts to perform so much better in another? The child is the same, it's the environment that changed. What's in that environment has changed. Is that the entire network, or is the individual and how they build themselves into that network? So foundations of social network analysis is both social and cognitive. We all have the urge to network, and the limitation of human abilities to foster many relations leads to two major motivations of forming the network. I'm saying the cognitive ability because think of your friends. You immediately right now, if you thought of your friends, you have 3, 5, 7, and maybe you start to stop at that number. If you're really a social butterfly, you could probably quickly name 12, 13, but that's about it, right? So most people name between 5 and 13 connections. More than that, and it becomes very hard to maintain that tight network of tight relationships. So we form relationships based on motivations to feel safe or to reach out. These two are opposite, because when we want to feel safe, we connect to people who provide comfort. When we want to reach out, we go to explore where we haven't been before, which is what teenagers often do. Sometimes there is also envy or status seeking, and that's a different type of network behavior where people try to become central in their own little network. So the way that we form network is lots of times informed by human actions, social circle and culture, as I've already mentioned, and the location. Just think about rural Indiana versus central New York. Those are very, very different networks. And networks are lots of times informal systems. So you have a very formal organization here with a beautiful building, but if you think about this, you don't communicate with people based on the natural organizational hierarchy. You have friends both inside and outside that structure. So we form those connections informally based on both node attributes and the network characteristics. Most ties are asymmetric. Just because I think of someone as friend, they don't necessarily think of me as a friend. And they're asymmetric. If I have a subordinate, they are not my supervisor, right? So it's a one-directional relationships. And when we look at asymmetric ties, doctor-patient, we can understand better the dynamics of almost any relationships. Now, the networks matter more than we know. And this is where I love to talk about elections of Hillary versus Trump. I don't care which side you're in, but when people say pollsters missed the ballpark, how could they not have? Think about this. Polls assume that every single person in the population has to have an equal chance of being selected into a sample of about 1,000 individuals that informs the general opinion of American public about who is going to get elected. Each one of these units has equal power. Think about the guy in rural Indiana and the guy in New York. The guy in rural Indiana is connected to 5, 15, 25 people. I just went to Iowa for Christmas break, and there was no place to sit in that house. Every single place was taken. There was so many relatives and friends that came over. You go to downtown New York, and you have a couple of friends over for New Year's party. So that guy in New York carried an opinion of 1 or 2 people around him. The guy in rural Indiana carried an opinion of 15 or 20. Therefore, things that I have highlighted is the fact that Trump would win was known back in March of that election year. Moreover, it didn't matter who one on the Democratic side. That was before the primaries were decided. Both Hillary and Sanders could have taken over any Republican candidate other than Trump. If Trump won the primaries, he won the presidential election. That was calculated based on, obviously, artificial intelligence because it's 20 million nodes, but using network data. Those relationships that pollsters ignore, those are the ones that tell us what is going on. So there are lots of networks purposes, and I'm going to go a little bit faster through this because we form ties to get things done, form community, feel safe, be effective. And there are lots of things that we do to network. And in fact, forming appropriate networks to get things done is called strategic intellect. It's a new term that appeared in 2017. Professor Shin Levine from Columbia. So communities motivate us to work very well, and we have cohesion when we're tied together, when we have dense relationship. You here really know the word contagion, right? That's how things spread, including COVID. Now, we have what is called mechanical solidarity. We have organic solidarity. Organic solidarity is that concept that we ourselves inform the environment that we live in. And belonging to a community is required for human survival. It's essential, and that's one of the, above food and water, of one of the most important characteristics that we can talk about. In fact, Maslow probably wasn't that far away when he was talking about belongingness. That was supposed to be a joke. I mean, everyone loves about Maslow's, hierarchy of needs, and they're saying that's a bad theory. All right, so when we talk about safety and affiliation, density is important. The closer we are to each other, the safer we are. When it comes to effect of time, networks change over time. Losing friends, even though, hopefully not losing them forever, just not being friends with them anymore, is an important part of development because we develop different attributes. What we call is grow apart. It's not that we grow apart with someone, we are growing together with someone else. That's all how I like to think about it. And one more important concept is in behavior versus out behavior. They call it in-group, out-group in sociology. It's really safety and affiliation to part of the dual in network analysis. And to become effective, we have to be independent. I already mentioned that if every single person in this room has access to all of the information that we need to get the work done, then why do we need so many people? Right? So we need to have those specializations and unique characteristics that are important. I'm going to go very quickly through applications of social network analysis because they're everywhere in anthropology, psychology, sociology, demography, political science, economics and finance, geography, urban planning, public health, management, education, physics, mathematics, and computer science. Now, there are a couple of major hypotheses that all of these subjects have in common. We're either looking at social influence. How is my surrounding affecting what I'm doing? Or we are talking about position. How is my position of power affecting what I'm doing? Then we have a social selection. How do I select friends based on what characteristics? If I'm a patient, how do I choose a doctor? Do I trust my insurance provider? Do I look at their picture? Doctors always have those awesome pictures. They never look like pictures in real life. There is a structural hypothesis, right? So what kind of structure do you need to have in order to be effective? There is what we call evolution and co-evolution. We each involve as human beings, but when we are part of a network, we co-involve because by changing, we change our structure around us. And then our little networks have global outcomes. So little state of rural Indiana with their tight networks, how do they inform, let's say, healthcare policy in the broader state of Indiana? And how does Indiana's healthcare policy relates to the healthcare policy available on the federal level? So how much of the influence that little rural Indiana area really has? So there could be multiple outcomes of interest. First of all, the network structure, the types themselves, how they related to outcome of interest. For example, food security. Indiana, as I've learned, is not really doing well in food security numbers. We are above average, which is not a good thing. When it comes to food insecurity, we want to be low. Do you have specific expectations of what should happen if network dynamics change? What is our outcome? Are we looking at individual? Are we looking at a couple? Are we looking at some other aggregation of those nodes? And what could be some interesting outcomes that we can see from our study? And here's the medical research, which is actually what was this all about, right? Again, I focused on social. I'm not really interested in examining the neural network of C. elegans because there's really nothing fun there. Once you've met that worm, you've met that worm. But when it comes to looking for Ebola, right? This is a study, I mean, it's an old study, 2015, but that outbreak that we all talked about, or at least in Russia, they were talking about in the news all the time, thinking that Ebola is going to take over Siberia. It can't, it's not densely populated enough. That was another joke that didn't go well. But it came from one single case. And then we can quickly map out how that virus evolved. I'm sure that people right now in laboratories are mapping out COVID, even though that mutated so fast in different communities. I would say give them a couple of years, they will have this picture for COVID as well. Social antecedents of obesity. Lots of times we hear, are your friends making you fat? The answer is yes, they are. And it's both from the standpoint of connections, it's from the standpoint of behavior, it's from the standpoint of food choices. If I'm going every day to go out to eat to McDonald's and I'm, hanging out with my friends, my friends are going to go to McDonald's with me. That has very important implications. Social pressure on smoking. It's actually interesting because it used to be that peer pressure, especially at teen years, were conducive to children starting smoking early, before the age of 18. It actually has changed since 1970s quite a bit. Now the pressure is opposite. The pressure is not to smoke, and network analysis tells us that people who smoke tend to go into the periphery of the major network structure. This is actually very encouraging to see that the social norm now is not to smoke. So all that work that you also have done in promoting healthy lifestyle has paid off. This is the unhappiness contagion. I'm sure we've all heard the adages that don't hang out with sad people, you'll become sad. Well, you can actually hang out with happy people to become happy. This is very, very true. Happy people tend to hang out together. Blue people who are, blue, unhappy, they tend to cluster together, green in between. Okay. And that's actually very common in many communities across societies, across religions, across many other characteristics. This is that example I've talked to you about, social effects of social isolation on diabetes. This is an ego network. The person in the center, we have two males up on top and two females on the bottom. We can only ask about their friends and family. We can also ask about how close they live together, the proximity, and how often they interact. And they have blue is, the blue and the pink themselves are men and women. Women tend to have slightly larger networks on average, even though for people with diabetes, that difference is not statistically significant. We also have partners, if there is a partner, that's dark red colored circles. And for comparative purposes in this particular study, all the ego networks had a partner. But then we also have family members and friends. And once that information was collected from many patients, and those ego networks were built, social isolation, or the lack of those important ties, has explained the rise of diabetes above and beyond any other physical characteristics that were present in those patients. Sentiment contagion. It's very similar to happy versus unhappy, but sentiment, we're talking about actually the online stuff, right? So we'll have Facebook. Well, I have a Facebook. I don't use it much. But remove those people that constantly whine how bad their life is, because that's contagious. Okay? Surround yourself by happy people on social networks. Most people are not that important there anyway. They're just some strangers. I have a social network on Facebook of, 1,500 people. I don't know if I know even 100 of them. So those who are negative are hidden from my feed. And this is a social determinant project, which is near and dear to my heart at Lucy Family Institute at the University of Notre Dame. We just opened an Accenture lab to work with social determinants of health. This one shows network effects of social determinants above and beyond all other medical and social network characteristics to explain the prevalence of cardiovascular diseases. One more slide. This is food nutrient network and heart disease. This one is a bimodal network, which means we have nodes of different types. Up until this point, I was talking about networks consisting of identical nodes, people, right? Specifically, or wireless towers. Well, we can build networks from people to objects. For example, which clubs do we belong to? Or which restaurants do we tend to frequent? I can build a network of people and talk a lot about their behavior based on which restaurants they go to. Well, here the network was built based on which foods people consume, and that network was then linked to heart disease. And we have beneficial foods with beneficial nutrients. We have harmful food with harmful nutrients. We have that relationship. And I think it's obvious for medical professionals that beneficial foods with beneficial nutrients actually leads to better heart health, but somehow McDonald's is still thrive. So obviously that message is not quite clear. That's why this network analysis was looking at that specific relationship, because some food might be beneficial, but not necessarily nutritious, right? Because when you think about celery, it's awesome for you, but how much nutritional value does it have? How many sticks of celery do you have to eat to get you 1,600 calories for the day? So I thought it was kind of fun little thing to show you as one more network, because it is bimodal. It has two different types of modes. You can have multiple modes. You can have people in teams, in groups, departments, organizations, industries, countries. The largest multimodal network I've worked with had 15 types of modes. I don't know if you can process more than that. I never had a need to. But imagine this multiple complex relationships when we can tell about organizations something by analyzing networks of people that work in them, irrespective of the departments or the industries that they're in. And with that, I am done with presentations, and I'll be happy to hear any questions that you may have.
Hello. So I really liked your comparison between Harry Potter and Lord of the Rings. And it made me think about the aspect of time, because particularly, if we're using Lord of the Rings as the example, there are characters and people who live for hundreds, if not thousands of years. So, excuse me, I'm just curious what kind of complexities are introduced into these analyses when you incorporate that time factor overall.
Well, that's an excellent question. Thank you. Time is actually a very important variable, because when we're examining items over time, we can look at attributes changing, and we can also look at how the networks has changed. I didn't bring any examples of an actual time-based network except the little dragon movie, just to show you that it can be done. But imagine we have high schoolers that start as juniors, and then we observe them over 4 years. We collect data at several points in time, like with any longitudinal analysis. We examine their networks. We examine their attributes, let's say, such as educational performance. One example that I had done in my lab was political attitudes. How does performance change based on the networks that people are in? How do political attitudes change? How do networks change when people start performing differently, or they join some political club or something like that? How would persons' health change if they got involved in a support group? Counselors know what they're doing. I mean, they're saying, well, find yourself a support group. They give specific pointers why. They understand the importance of it. But can we trace that evolution? And yes, we can. Time is just a variable. So basically, we build those networks for each period of time. We compare their structure, how they're different. We compare the attributes. So what I've showed you is just graphic analysis, because network analytics, unlike other statistics, is very easy. To make that movie, it's one command. You build the data sets, but then it's one command. It can be taught very quickly to almost anyone, unlike traditional statistics where you have to take courses. So you can examine the dynamic visually, or you can run very complex models, including link prediction. So if we have information about the nodes and we have time series development of the network, we can predict who is going to connect to whom. And moreover, we can predict how their attributes will change.
Thank you for a great talk. So as you pointed out, network analysis has a lot of potential application in healthcare. Your last examples spoke to that, but I'm wondering which healthcare settings actually have done anything with it. If you ask the average medical student or even physician what network analysis is, you probably will get a blank stare. So Has this had any practical impact in terms of how we help people either get healthy or stay healthy?
Well, I think one field that does network analysis is epidemiology, because they trace the development and spread of different diseases. In fact, the same network model type that's called diffusion, how something spreads through the network, because of epidemiological work, is called contagion. Diffusion and contagion is the same thing. There are some modeling differences, but it's the same thing. Outside of that, I just don't even know how much physicians or other healthcare practitioners being taught regular statistics. I think they're being shown simple bar charts, and maybe they get an introduction into statistics with regression analysis. I would say that even outside the medical field, networks are not widely taught in different fields. I wasn't taught this explicitly. I just happened to stumble across this field by chance, and it changed my life. So I think there is a lot of potential. There is a lot of medical research. Harvard has a research laboratory on epidemiology, and it's being led by Dr. David Lazar, that does a lot of these medical studies. And examples that I've shown you are all actual published studies. But I don't know how much we need to talk to physicians, for example, about the effect of social networks of their patients and how much that social network affects the patient's behavior and treatment effects. I think it's very important, and I'm glad that this was probably perhaps somewhat new to some of you, so that maybe we can have courses on network analysis for people who inform education for medical practitioners. And it doesn't mean that physicians need to learn network modeling, but if they understand the basic concepts, it will be on their mind. So I would be very happy to continue the discussion with you about offering a certificate program, let's say, out of University of Notre Dame. I am presenting AnalytiXIN. I did not talk about that a whole lot. It's a major grant from the Lilly Foundation, $36 million divided between 3 universities, AU, Purdue, Notre Dame, and several major Indiana companies, to bring together industry and advanced analytics. So if we offer a certificate program, it's paid for by that $36 million grant for as long as the grant is here. So we can think of some cooperation opportunities if you think some of this training could be useful to people that at least inform data analytic decisions, so that they consider network connections within their data that they collect.
Sorry, we have a question online. Thank you so much for your talk. It was wonderful. My name is Gerard. I'm a dual fellow in clinical informatics and peds hematology/oncology. Would it be feasible to build a network to evaluate the impact of social determinants of health on mortality with patients? Sorry. One second. On patients with sickle cell disease. And then he continues, also, I've worked with Laszlo Barabasi, who used network analysis to evaluate cancer networks, which was my initial exposure. It was a great application of medical knowledge, in my opinion.
Well, thank you. Yeah, there are several big names in social network analysis. Barabasi is one of them. Lazar is another. There is also Nosh Contractor, and there is Indiana's own Stanley Wasserman, who was my teacher and who actually was the founding director of the lab that I ran for 10 years. So those are big names, and people have, these big names have dashed into every single area of network applications just to show that it can be done, but not a whole lot of studies are being done. Having said that, at Lucy Family Institute, we have a project in Mexico with a Mexican hospital that's a cancer hospital for children. And right now we are working on a project that evaluates the effect of social networks of caregivers on the child's survival rate, on the child's well-being, progress, remission rates, things like that. Not the children themselves, the caregivers, because the children are embedded in the networks of their caregivers. So if the caregiver loses that ties to the community, that has a very direct and very strong impact on the child. So yes, it absolutely can be done. I don't know if a specific disease has something to do with it. If I understand the question correctly, sickle cell is has a genetic component, so we can probably trace that genetically. So we absolutely can build any network of any relatives from that point. Now we can also build genetic networks, so we can go into that, C. elegans and map out a little part of a human body the same way. So yes, it's absolutely can be done. So my contact information is actually next. So you can just email to the AnalytiXIN at ND, or you can email to me at kuskova@nd.edu, and I'll be happy to point you in the right direction or just talk to you about this project. If there are any other questions, please feel free to email me. I'm very easily reachable at any of the emails. I'm also very Googleable. So if you want to just reach me directly, you can just write to me at Notre Dame address, and I'll be happy to continue this discussion. In fact, this talk, and I want to thank you very much for inviting me to it, it came out of another talk I gave at BioCrossroads celebration, 20th celebration event, when I just begged people, come over and give me some projects to do. When you think that you have the money and you have this excellent expertise at your disposal at Notre Dame, there will be a line of people waiting to collaborate with us. There is no line. In fact, I have to go actively ask for those collaborations. So I do want to qualify again that for another year, my work and the work of the teams that I can assemble is fully paid for by the generous grant from the Lilly Foundation. So it could be education, it could be collaboration, it could be your specific analytics problems. Let's say you have a data set and you don't know what to do with it. We'll get you expertise, whether it will be student, graduate student, or faculty members that will get paid by us to work on your problem. And not only work on it, but actually teach, because there is one of those, professional deformities in academia. We love to teach. It's like, we can always do something else, but it's so much more fun to teach. So we'll be happy to collaborate on any of those projects. So please contact me. We'll be happy to do that.
Thank you so much, Valya. Are there any other questions online? I just want to check and make sure we didn't leave any. Okay, thank you so much. Thanks everyone for joining us today.